Hi everyone, welcome to day 2 of Just Enough Python for AI. Yesterday, that is on day 1, we saw how we could create a Jupyter notebook and we wrote our first line of code, that is printing just enough is enough. Today we will do a lot more. As you can see, we have a lot of code, lot of examples to go through for today's video. Let's get started. Today's video, that is the day 2, and tomorrow's video, that is day 3, along with yesterday's video, are part of module 1. As part of this module, you will set up your Python coding environment, which we did yesterday, learn to handle data and variables and types, which we'll do today, and then we'll get comfortable with loops and conditions. That is for tomorrow. For today's video, we will learn about variables, we'll learn about different data types, that is numbers, strings, and booleans, and we'll also do some basic arithmetic and comparison operations. Let's first look at what are variables. A variable in Python is like a label you stick on a piece of data so you don't forget it later. Variable lets you store data. You can name them anything with some exceptions. We will go through the naming rules of variable just in a bit. Let's first create a variable. How do we create a variable? Very simple. This is our variable which is named x and it stores the value, that is 42. So we are creating a variable named x and assigning it a value of 42. Here we are creating a variable named language and assigning it a value which is a string Python. Here we have a variable named pi and we are assigning it the value of pi, that is 3.14159 and so on. So this is how you create a variable. You give it a name, any name that you want. We will go through the rules of naming just in a bit, and you assign it a value that it must hold. Right here, we can notice a few things. First being different data types. This 42 is an integer, this Python is a string, and this 3.14159 is a float. Moreover, unlike most of the other languages where you must specify the data type while you are declaring a variable, Python doesn't need that. So you can see that I have nowhere mentioned that x is an integer, language is a string, or pi is a float. Python is smart enough to understand. It looks at the data that we are assigning to the variable and it understands the type of data. And that's what I have mentioned here. Python is a dynamically typed language, which means you don't need to declare the type of variable before assigning a value to it. This makes Python flexible and easy to use. Let's quickly execute this code. You can't see anything yet because we are not printing any output, but I can assure you that we have created 3 variables here. Further down the line, we will do some operations using these variables and then you will be able to see that we did create variables and it holds the value that we have assigned to it. But before that, first let's look at the rules for naming the variables. And there are very few of them. The first one being a variable name cannot start with a number. So the first example is equal to 25 is absolutely fine, but the second one, too fast, too furious, is not. We cannot name our variable too fast, too furious because it is starting with a number. That's the first rule. The second rule is that there should not be any space between 2 words of a variable name. If you look at the first example, we have first underscore name. This is fine because there are no spaces in between. But the second example where it says last space name is not a valid variable name. This is not right and Python will complain if you try to do this. By the way, we very often use underscore in place of space, but that's not a rule. It's not a Python rule that you must use underscore only. Python will be happy as long as there is no space in between. We use underscore because it makes the variable named readable. The next rule is to not use weird special characters. Do not use weird special characters. Stick to letters, numbers, and mostly underscores. Also, Python is case sensitive. So this variable is not same as this variable because here it's starting with the uppercase N and here is starting with a lowercase n. So even though the name of the variable is still same, name, but one is starting with the uppercase and the other one starting with a lowercase, so they are two different variables. Python will treat them as two different variables. Now let's look at different data types. Here are the basic Python data types, the first one being integer, the next one being floating points, then string and booleans. Now integer, as the name suggests, would hold whole numbers, whether positive or negative, no decimal points. Any number that has a decimal point, 3.14 or minus 0.5 or 2.71 blah blah blah, all will be floating points or floating numbers. Then strings represent any textual data. So an example being hello Python or just enough Python are all strings. Strings are always wrapped in quotes, and you can do a lot of operations with these strings. You can slice them up, you can concatenate them. We'll see all these examples just in a bit. The next data type is Booleans. Booleans are basically true and false, and they are used for checking conditions or when making decisions in your code. We'll look at examples just now. Let's execute this code again. Here we are assigning the value 30 to age, which is an integer, then 19.99 to price, which is float. This Python is a string being assigned to the variable name, and this true, do notice that T is capital, uppercase. Then this true is the Boolean value true and is being assigned to this variable is exciting. So now that we have created these variables, we still don't know if anything really happened. All we could see is that there is a green tick mark, it says success, but there is nothing for us to see as an output. Now we will do some operations on our variables and see if the variable was created or not. The first one being, we want to check the data type of our variables. We know that this one is age is integer, price is float, name is string, and is exciting is true. But is it really true? Let's check that. We'll execute this code here. We have a built-in function, built-in Python function that we can use to check the data type of the variable. And how to use it? Very simple. You type, and then you pass the variable name in the bracket, in parentheses. And then we have the print statement to actually print the output right here. So as you can see, the type of age is integer, which is int. The type of price is float. The type of name is string. And the type of is exciting is Boolean. So we do have our variables that we created here, and we just confirm that by checking the type of those variables. Using this type function to check the data type is quite useful, especially when you are ingesting data from external data sets. You want to be sure that Python is interpreting the data type correctly. So now that we have created our variable, we have also confirmed that it's there. Let's do something with this. Let's play with our variables. Let's do some basic operations on our variables. We'll start with some basic mathematical operations. The first one being plus, minus, multiplication, division, modulus, and exponent. We can do all that on our variables. Next, we can do some comparison as well. We can check if, for example, if you have a variable named A and a variable named B, we can check if A is equal to B or not, if A is greater than equal to B or not, and so on. We'll see some examples, then it will be clear. And then next, we can also look at some assignment operations. Let's first execute this code and then we'll look at the examples. So here we have a variable named A and we are assigning the value 10 to it. Then here we have the variable named B and we are assigning the value 3 to it. So A is equal to 10 and B is equal to 3. Our first examples are arithmetic examples. We are saying print A plus B, we should ideally get 13. A minus B, we should get 7. A multiplied by B should be 30. And A divided by B should be 3.333 and so on. And then we have A exponent B, that is 10 to the power 3, should be 1000. Let's look at our answers here. We have 13, 7, 30, 3.333 and so on. And then 1000 as expected. In Python, the arithmetic operations are as simple as this. When you want to do a sum, you just say a plus b. When you want to subtract, you say a minus b, and so on. The print is there just so that we can see the output right here. Next, let's look at the comparison operations. So here we are checking if a is equal to b or not. A is equal to b or not. Do notice that we have two equal to operators here, unlike here where you have one equal to. Here we are assigning a value. Here we are checking if the values are same or not. If we had said something like this, a equal to b with only one equal to operators, then we are basically assigning the value of b to a. After executing this code, your a will hold the value 3, not 10. We want to do a comparison. We don't want to assign the value. Then we need to put two equal to operators. This right here, we are comparing. We are checking if the values are same or not. If a is equal to b or not. We are not assigning the value of b to a. Let's check the output of this. Is a equal to b? The answer is false. Obviously, a is not equal to b. A is 10 while b is 3. Hence, you're getting false. Is a greater than b? Yes, because 10 is greater than 3. Hence, you're getting a true. The next one is assignment operations. This we have already seen right here. We are assigning a value to a variable. We are assigning the value 4 to a new variable named c. Then here we are assigning the value of a plus b to c. After this line, c is no longer equal to 4. C is now a plus b, which is 13. 10 plus 3 is 13. So now c is holding 13. And then we have a equal to a plus 2, which is 10, 10 plus 2. So here a now would become 12. But Python has a smarter and a shortcut for representing this piece of code. Instead of saying a equal to a plus 2, you can actually say a plus equal to 2. As long as you have the same variable both on the left hand side and on the right hand side, this notation will work. You're basically incrementing the value of a by 2 and then assigning it back to the same variable. This notation can be written like this. Instead of saying a is equal to a plus 2, you can write a plus equal to 2. This also works other way, that is when you are subtracting. Instead of writing a is equal to a minus 3, you can say a minus equal to 3. It might be a bit confusing now since you are seeing this shortcut notation for the first time. But as you write this code, as you write more and more of Python, this will be much more easier. This is simply a shortcut way of writing the same thing. So now if you look at the output, our a here was already 12. Now we are again saying a is equal to a plus 2. By the way, this is same as a is equal to a plus 2. So now it is 14. And then here a is equal to a minus 3. That is 14 minus 3. Then it should be 11. 14 minus 3 is 11. And that's what we are getting here. 14 and 11. The output of this and this. Next, we will look at some examples of string manipulation. Python allows you to do a lot with your strings. Let's look at some examples to understand what operations we can do with our strings. The first one is slicing. So as the name suggests, we are slicing the string. We can slice a longer string to create new smaller strings. Let's look at this example. Let's first execute this code and see what we get. So we have this variable named text and it holds the string value Python rocks. This string Python rocks is essentially a fused version of two words Python and rocks. What if you want to extract the individual words, that is Python and rocks? Then we can do something like this, the output of which are the individual words, that is Python and rocks. We are essentially slicing this bigger text into two smaller text. Let's understand what's happening here. So we are saying this text is the same as here, this text variable, but instead of printing the whole string, we are saying start from 0, 0 is the index, and go till 6. In Python, every character of this string Pythonrocks. Every character is assigned an index, and the index starts with 0, not 1. So this P, the first character, this uppercase P has the index of 0, not 1. Very important to keep in mind, in Python, all the indexes starts with 0. So this P has the index 0. Here we are saying start from 0. So this P is included and then go till index 6. So if you count from P, this is 1, then 2, then 3, then 4, then 5, and then 6, and then R, the capital R of rocks is the index 6. But if you look at this output, we don't have this capital R, this uppercase R in our output. That is because if you see here, the start is 0 is included. The end is 6 is excluded. So even though we are saying start from 0 and go till 6, we don't include the 6. We only include the character till index 5. So if you really want to print till index 6, then you must put here 7, not 6. Let's revise this again. Here we are saying print the text variable, which is here. The text variable is Python rocks, but we are saying don't print the entire string. Start from 0, go till 5, not 6. When we need to print till 5, we put here 6 because the end is always excluded. The end index is excluded. So essentially we are saying you go start from 0 and go till index 5, which will give you Python, Python. This is an example of slicing from the left, but we can also slice from the right. How we do that? The next example is slicing from the right. Since this string is not very long, we can actually count from the left 0, 1, 2, 3, 4, 5, 6 and so on, and we can check what is the index for this last character, that is small lowercase s. But what if it's a big string? So instead of counting from left, we can also count from right. When you count from right, we count from -1. So the index for this s is -1. -1, not -0. There is no concept of -0. Okay. This is -1. This s is -1. Then -2, -3, -4, -5. As you go from right to left, you go from -1, -2, -3, and so on. So this, the index of R, this uppercase R from right is -5. And then we have this colon. This colon separates the starting index and the ending index. And then after this colon, we have nothing. When we have nothing, we are essentially telling Python that go till the very end. So we are saying that go from -5, which is this capital R, uppercase R, and go till very end. So you get ROCKS, rocks. This is how you can slice a string. Here we are directly printing the output of this slicing, but we can even assign this sliced output to a new variable. We could have said something like first is equal to this, and then second is equal to this. In this example, we are assigning this sliced output to a new variable, and then you can do whatever you want with this new variable instead of just printing the output. And you may have noticed that while I was typing, I'm getting this auto-complete suggestions. That is because I have GitHub Copilot on my in my VS Code. I would strongly recommend not to have GitHub Copilot or any other AI assistant for coding in the beginning. At least in the beginning, while you are learning Python for the first couple of months, maybe first 1-2 months, do not take help of any AI assistant, because it will never give you even time to think. While you are typing, it will give you the output most of the time. But you need to think and then write yourself. That is the only way you can learn any coding language. I'm not against any coding AI assistants. In fact, people should use them. It makes you more productive, but not in the beginning. Wait for a couple of months, have some grasp on your own coding, and then be my guest, use the AI coding assistance of your choice and use as much as you want. In fact, you should use it. In this AI era, if you're not using AI, you are being dumb, but not in the beginning. Learn the language to some extent and then start using AI assistance. In fact, later you can even use other IDs like Cursor or Windsurf. They are basically AI coding tools based on VS Code. So they took the VS Code, they forked it, and they created their own IDs primarily for AI coding. But don't use them in the beginning. Wait for a couple of months, 1-2 months is enough. Learn some coding, have some grasp, and then start using them. It's okay to use them after a couple of months. Now let's execute this code and you will see that the output of these two is also same, Python rocks. Now here, this was an example of slicing a string into multiple smaller strings, but can you add multiple strings together and create a bigger string? The answer is absolutely yes. That's called concatenation. You can combine strings using the plus operator. Very similar to the plus of a plus b here, right? We had a plus b, the arithmetic operation where we were adding two numbers. Simply using that same operator for two strings concatenates the two strings. Let's look at this example. Our first string is just enough and our second string is Python. Actually, if you notice, the variable name is same as what we used here, which is not a good practice. We should not reuse the same variable names, but here it's okay. Once I execute this code, the variables will be overwritten. So here, even though the variable name first had the value Python and the variable second had the word rocks, but once I execute this code, these two will be overwritten and first will be just enough and second will be Python. And then we are creating a third variable named combine, which is equal to first plus, this is simply a space. We want to have a space in between. So here we are putting a space in between and then we are adding the second variable, which is named second. The output of that will be just enough Python. Just enough came from the first variable. Then we have this space here, which came from this, and then Python, which came from the second variable. So this is how you can combine two or multiple strings together. Now let's look at the next example, that is F string formatting. To understand this, let's first execute this code. Let's look at this output, which says, hello, Babu Rao, welcome to the year 2025. But if you notice here, we don't have Babu Rao here, we don't have 2025 here. What we have here is a placeholder for name and a placeholder for year. And these placeholders get replaced by the actual variable name. The variable is right here, name, and the value is Babu Rao. So this placeholder will get replaced by the value that this variable contains. So the value that name contains is Babu Rao, and the value that this placeholder, this year variable contains is 2025. These placeholders will be replaced by the actual values and you can get the string like this. Hello, Babu Rao, welcome to the year 2025. Now this is a very simple example, but this is very helpful when you want to print something and you have a part of that string dynamic. You want to change the part of that string dynamically while you are printing. This name and this year is being printed dynamically while rest of the string is static. You can have an example where you have names of 10 different people and then there are 10 different years and you want to print 10 different lines. The rest of the stuff remains same, but the name and the year has to be different on each line, in each line. In that case, this string formatting, this F string formatting is very helpful. The syntax is very simple. You have this mandatory lowercase f to begin with, and then you have the whole string within quotes, and then in between, wherever you need to replace a part of that string, the dynamic part of the string, there you have the placeholder with the variable names within curly brackets. That is your F string formatting. I can see a spelling mistake here, formatting. Now let's look at another example of string manipulation. We have a variable named laugh and we have ha with a space, and instead of this plus operator here, we were using plus operator here. Here we are using multiplication operator. What will it print? Let's see. Ha 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 ha, because we did 5. If we did 3 here, it will be 3 times. If we do 10 here, it does print ha 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 10 times. Basically, you are concatenating the same string 10 times. We'll see more examples of string manipulation, string concatenation, slicing and all in our upcoming videos when we'll have more complex use cases. But for today, I think it's enough. Next, let's look at some Boolean examples. So what exactly is Boolean? Boolean is basically true or false. Boolean helps you evaluate conditions, whether the condition is true or false. So here, if you see this first example, we have a variable is greater and we are assigning a value to it. What is the value? The value itself is the output of is 10 greater than 5. Is 10 greater than 5? Yes, it is, right? 10 is greater than 5. So the output of this comparison is true, Boolean true. Similarly, the output of this comparison, that is 5 equal to 10, is false because 5 is not equal to 10. Now here, this output true is being assigned to is greater, and then this output that is false is being assigned to this variable named is equal. And then we are printing the output. If you see the output of this print statement is true, while the output of this second print statement is false. This brings us to the end of today's video. We'll see a lot more examples of Boolean in tomorrow's video when we cover if-else conditions. But as promised, we are not yet completely done. At the end, we have a couple of questions, couple of quick exercises for you guys to attempt. Nothing very fancy or very difficult. All the questions are based on concepts that we just learned. I'm pretty sure everybody will be able to get through these questions. If not, if you face any problems or any confusion, you can reach out to me in the comment box. And I will anyway give answers to these questions at the end of tomorrow's video, so you can cross-check your solutions. And you can access this notebook and download this notebook and all the other notebooks from this series from the GitHub repo link that is there in the description and the first comment. This finally brings us to the absolute end of today's video. Tomorrow we will look at conditions and loops, very important concepts. I hope you liked this video. If so, please like and subscribe. I will see you in the next video.